This is the second mini lecture for section 7.1. We ended the last mini lecture by asking a question. We saw that every terminating decimal represents a rational number. That is, a number that can be written as a fraction. Now we'd like to know the answer to the following question. Which fractions have decimal expansions that terminate? You think about something like 1/3. I'm sure you all know that 1/3 does not terminate. Okay, but there's lots of fractions that we know if we write them as decimals, they do terminate. They stop at some point. So so that's our question then. Which fractions give you terminating decimals, and how can you tell before you actually work it out? So let's begin with a few examples that we probably already know have terminating decimal expansions. And I'll start with the most obvious one, which is 1/2. I'm sure you all know that that's 0.5, but let's think about why that is. No calculators. We want a pencil and paper explanation. And the answer is that, well, this is 5/10. Because it's 5/10, that's what we define as 0.5. 0.5 means 5/10. Okay, let's try something similar. Let's try 3/4. So probably you all know that that's 0.75. But again, I want to be able to explain that just using a pencil and paper explanation. I don't want to use a calculator. How do I know that that's 0.75? Well, for 1/2, we had this trick where we wrote it as something over 10. That's not going to work here because 4 does not go into 10. But it does go into 100. I could multiply top and bottom by 25, and I'd get 75 over 100. Which is 0.75. Dividing by 100 moves the decimal point 2 places to the left, and that's what we're doing here. Okay, or I could take something like, let's say 2/5. Well, 5 does go into 10. So multiply top and bottom by 4. It's 4/10. So it's 0.4. Let's try another one. Let's try 7/20. So again, what I want to think about is, what power of 10 does 20 go into? Doesn't go into 10, obviously, but it does go into 100. So let me write it out using the fundamental law of fractions this time, just so it's really clear what I'm doing. I multiply top and bottom by 5, which I know gives me an equivalent fraction. And the reason I'm doing this is because it gives me 100 as the denominator. And 7 times 5 is 35. So I get 0.35. Let's try another one. Let's try 3/8. So here, to expedite the work, I'm going to use my calculator a little bit. This is something that you could do equally well on paper, but we'll just agree that we're only going to use the calculator to test divisibility to shorten the work. I don't want to do 3 divided by 8 on the calculator. Okay, but what I'm looking for is a power of 10 that 8 goes into. And I know that 8 does not go into 10. If I do 100 divided by 8, well, it doesn't go into 100. So let's try 1,000. Well, that goes in there 125 times. So what I can do is multiply both sides of this by or top and bottom rather, by 125. And on the bottom I get 1,000, which is what I was shooting for. On the top I get 375. So that comes out to 0.375. Okay, and yeah, so on and so forth. So the idea here would be to write the fraction as an equivalent fraction with the power of 10 in the denominator. 10 or 100 or 1,000 or 10,000 or what have you. Now, let's think about each of these denominators that I started with. See, we had 2, and we had 4, which is 2 times 2, and then 5 is just 5. 20 is 2 times 2 times 5. 8 is 2 times 2 times 2. You know, what do all these have in common? Well, they're all, you know, products of 2's and 5's. So let me make up one more example just to kind of test what might be a hypothesis here. Let's try let's try 40. 13 over 40. Okay, 40 does not go into 10, obviously. Does not go into 100. It does go into 1,000. If I multiply the top and the bottom by 25, get 13 times 25, which is 325. And then 40 times 25 is 1,000. So that's 0.325. And then 40, of course, is 2 times 2 times 2 times 5. So what we might guess here is that, you know, you can write a fraction as a terminating decimal if the denominator is a product of 2's and 5's. So let's think about why that might be true. If a over b is a fraction with a terminating decimal expansion, then we must be able to write it as something over 10 to the r, something over a power of 10. Now, if a over b is in simplest form, so we'll assume it's a reduced fraction, it's in simplest form, that means that b would have to be a divisor of 10 to the r. Well, 10 to the r is a product of 2's and 5's. That's because 10 is 2 times 5. So for example, 1,000 is 2 times 5 times 2 times 5 times 2 times 5. And we know that anything dividing into such a number is itself going to have to be a product of 2's and 5's. So the only way that b could be a divisor of a number like that is if its own prime factorization is just 2's and 5's. So you know, our partial answer at this point then is that a fraction a over b in simplest form has a terminating decimal expansion if and only if the prime factorization of b consists of just 2's and 5's. So that would be like 2, 4, 5, 20, 8, and 40. Okay, those are all products of just 2's and 5's. Now, what about all the other fractions? For example, what about 1/3? Okay, you probably know that 1/3 is 0.33333, where the 3's keep going forever. Because, you know, maybe you've done that on your calculator. So everyone kind of knows that, but not everyone knows why. So to see why that's true, let's let x be 0.333333 and so on. Then if I do 10 times x, like I'm doing here, then it moves the decimal point one place to the right. So it's going to be 3.333333 forever. X itself is 0.333333 forever. So if I take the difference, 10x minus 1x is 9x. And then this number minus this number is going to give me just 3, because all the decimal the decimal numerals cancel out. And so I'm left with just 9x equals 3, which means that x is 3/9, which is 1/3. So it's strange, but true, that the number 1 is actually exactly the same as 0.999999, where the 9s keep repeating. That strikes a lot of people as strange, because it seems like this would have to be less than 1. But actually it's not. They're exactly the same. And so this is one of the weird things that can arise with decimals that you may not have noticed before, that sometimes there are more than one way to write the same number as a decimal expansion. And sometimes when you play around with a calculator, when you expect to get the number 1, you might get this 0.999999 thing. And probably you learn to interpret that as 1.